Hi everyone, my name is Dasha. I'm a tutor at Kweller Prep and I'm a graduate of Hunter College High School. This is the second part of our three-part webinar on the Hunter College High School entrance exam. Today we'll be focused on the math portion of the exam. So I wanted to briefly recap some of the things we spoke about yesterday. We focused on the reading portion and briefly talked about what it takes to qualify for taking the exam. So Hunter has released the score requirements for this year for the ELA and math state tests. But if your child does not take the state tests, attends private school or so forth, they do give additional criteria for being able to take the exam. And you can also find this on their website. We talked about this a bit yesterday. Happy to answer any questions, and Kweller does a really great job at helping navigate any of these challenges along the way. Then we talked a little bit about what the exam looks like. We said there were 50 ELA, a writing assignment, and 30 math questions. And we said that math and English questions are weighed the same, and the writing portion is graded separately. And the way it works is that your reading and math score is combined into a multiple choice total score, and then the top, I believe it's 500 scores, have their essays graded, and then those essays are the determining factor for who has gained admission. Now this may change. Things have changed over the years, so this may change again. But we still have to, do our best in each of the sections. There are, unlike many other exams your child may have taken, there are 5+ possible answer choices for each multiple choice question, and, which means more answer choices, more possible trap questions. And we'll talk more about this when we see the math. There is also no penalty for guessing. So we do talk about in our courses, what to do if I'm running out of time or if I don't answer questions. You can guess and just bubble in randomly. Time management is of the essence here. They tell us in the instructions, as soon as you finish one section of the test, go on to the next section. You have to monitor the time the proctor writes on the board. This is their way of saying they're not going to tell you what order to do the test in or how much time to allocate per section. Students are given one test packet and are given 3 hours, and you have complete freedom over how to use that time. And with that freedom comes also great responsibility of time management. So because we have 3 hours for the exam, including the writing portion, we at Kweller generally recommend spending an hour per section. Now this can vary a little bit based on each student's strengths and weaknesses, and of course, we can't force you to do it one way or another. Some students have stronger reading or math skills, so may want to dedicate more time to their weaker section, but usually that might be in a range of 10 or so minutes. And then we do either way recommend spending about an hour on the essay portion. The order in which you do the test also does not matter. So some students prefer to start with their stronger topic to get it out of the way, whether it's reading or math, and then do the essay in the middle, and then end off with their hardest portion. Some people do it in the reverse. The beauty of taking a course in which there will be multiple opportunities for diagnostic tests is to really give you the opportunity to try different things and see what works for you and doesn't work for you. We encourage students to try different test-taking strategies each time, whether it's start with the essay one time, or leave it off till the end, or do it in the middle, or start with your harder section, or start with your easier section. And by manipulating all these things in practice tests, by the end of the course, you're really in a good headspace to figure out, this is what works best for me, and this is what I should replicate on the day of the exam. So let's talk about math. The timing. We said that we have about 30 math questions in 1 hour. That gives us about 2 minutes per question. Some questions take longer, others take shorter. So we try not to say have a firm 2 minutes per question, but it's a good general guideline. Generally, the test questions tend to get harder as they progress. Now, that's not necessarily always true. There's sometimes quick and easy questions towards the end. There's sometimes tough questions in the beginning, but you can skip around. So if you see that a question, the approach is going to take you more than a couple of minutes, we say flag it and then do it at the end when you have time. So you can get through the bulk of the easy questions in the beginning, if that makes sense. So a really common question we get is, how much math do I need to know? Because everyone hears people say, oh, the math section is so hard, the Hunter test is so hard. And we're not saying it's easy. But we're not saying that your child needs to start learning 7th and 8th grade math curriculum. Nothing on the test tests beyond the formulas, concepts, or any topics that your child has likely already covered in 6th grade. That's really important. That may depend school to school. So not to say that, every single topic and every single thing is on there, but for the majority of things, you don't need to go beyond what you have learned in that sense. But it does test these topics in a way that you may not have approached before. So let's talk about that. What are the math questions like? They focus predominantly on pattern recognition, problem solving, and logical reasoning. Patterns are a really big one here. They're asking you to look at a question that might look very long, might look like it could take a lot of time and require a lot of effort, and say, can you find a way to make this short? Can you find a way to actually answer this question in 2 minutes? And that's what we teach. And that's an incredibly hard thing to teach because it's teaching you a new way to think, a new way to use the information that you know and apply it to these questions. But as I have said yesterday with the reading portion, the foundational skills that you learn preparing for the Hunter test are skills that will take you through the rest of your academic career. So I said the same reading that's on this test is the same reading that's on the SHSAT should you choose to take it in 8th grade, and the same reading that's on the PSAT and the SAT and most standardized tests. So the skills that we learned in the reading, for example, active reading, underlining, annotating, identifying question types, all of those skills will stay the same as you go along. Similar, but not the same for the math. Obviously, as you progress in grades and get older, the math obviously gets harder, right? You learn new concepts, you're going to learn statistics, you're going to learn geometry, algebra, more and more complex concepts and formulas. But the way to approach a question, the organization skills, the pattern recognition is something that you're going to need in any grade level, in any math that you ever do. And so studying it here is a great step forward. So what do we mean by this? Here's an example of what I mean by a pattern recognition question. Now this isn't directly from the Hunter exam, but it's a good intro level question. What is the sum of all the numbers from 1 to 100? This is an easy question, right? No tricks, just addition. But how do we do it efficiently, right? Some of you may have learned this in school or found it as something fun to share with your friends. But how do we do it? And if some of you know the answer, you're welcome to share it in the chat. But essentially, you could sit down and you could add all these numbers. In fact, if you do it efficiently and write stuff down, it might not even take you too long. But on the Hunter test, like we said, you have 2 minutes. So how can you solve this in under 2 minutes? Well, there is a developed method called the rainbow method, which is where all those numbers in a list, you pair them up with the first and last and work inwards. So now we have 50 pairs of 101. and 50 times 101 is 5,050. So what was originally a really long addition problem can be turned into very simple multiplication, right? You're just multiplying two numbers. This is my way of illustrating the idea of what math questions look like on the Hunter test. Now, they're not all this simple, but it's the idea of taking something that looks very complicated and looks very long and looks like it's going to take me a lot of time and flipping it and finding a pattern, a shortcut, a way to do it efficiently. So let's look at some more math questions from Hunter Exam 2. This was on the released exam. This is the first page of the math problems. So we had the first 50 questions were reading, and now we have question 51, 52, 53, and so forth. Page 1, these first few questions, I say is generally somewhat easier. Now, that's not always the case. There can be curveballs and there can be easy questions at the end, but I like to say that this first page should be a good kind of segue into the math portion of the test. It kind of gets the brain flowing without being immediately worrisome. So let's take a look at some of these questions. As I said in the very beginning of the session, I encourage you to grab a pen and pencil and work alongside us. I will have the answers for these questions on the following slides, so if you want to solve this with us, you're welcome to. So the first one, what is the value of the expression 7 minus 1 times 0 plus 3 divided by 3? Now this is a classic PEMDAS question, or the order of operations, something you likely have already learned in school. So how would we solve this problem? We would have to do each step of this expression following the order of operations. There's no parentheses, there's no exponents, so we have to do multiplication, division left to right, and then we do addition, subtraction left to right. In the next slide, I'll show you some of the common traps we can fall into as well with these questions. The second one, of all the fractions with a denominator of 17 and a whole number numerator, how many are between 1/3 and 2/3? Now, this is a question about working with fractions. And when I say that the Hunter test takes concepts that you've already learned, but shows them to you in a different way, this is what I mean. You've learned fractions. You've learned how to convert fractions, how to add and subtract, and so forth. But what does this mean? A question that's asking us how many are between 1/3 and 2/3 with a denominator of 17. It might not make sense of what the question is asking originally. So even though it doesn't require any math skills beyond what you know, it does require some thinking of how do I approach this and what do I need to do here. So again, I see some people are responding in the chat, which is great. If you have a chance to try this out as well, you're welcome to throw that in there. And then same with 53. 53 says, what is 15% of the sum of 3 1/2 plus 7/4 plus 0.75? Now, this is a question asking us to work with percentages, fractions, and decimals. I should have added in there as well. So something you might have learned in school is converting between fractions, decimals, and percentages. And this question, as you can see, combines all of them into one. So I'll give you a minute if you want to do them alongside us, and then we'll talk through the explanations. And you're welcome to ask any questions in the chat as well. I would also note that we talk about in our classes a lot test-taking strategies and different approaches to questions. And many math tests in school are not multiple choice, right? They want you to show your work and they want the teachers want to check how you got your answers and that you didn't guess. And for many people starting off taking the Hunter test, the math portion might seem, well, if I have enough time and I can brute force it, I can plug in all the answer choices. And as we see both here and in questions we'll see in the future, that's not always the case. There's trap answers that we'll see, and sometimes the questions are made in a way that you can't just plug them in. So even though it's multiple choice, it's not making the questions any easier. All right. Let's see if you guys got any of these right. Let's take a look. So for the first one, 7 minus 1 times 0 plus 3 divided by 3. So on the right side of my handwriting there is the right approach here. First, we do the multiplication and the division. 7 minus, so 1 times 0 is 0. 3 divided by 3 is 1. 7 minus 0 plus 1 is 8. The correct answer for 51 was E. However, right, there are trap answers. There's actually many trap answers depending on how you do this problem. But one that I thought was easy was that if you don't do PEMDAS and you do it straight across, like I did incorrectly on the left side, 7 minus 1 is 6, 6 times 0 is 0, 0 plus 3 is 3, 3 divided by 3 is 1. And take a look at that. Answer choice B is there. So one of the challenging parts about Hunter is that they know what the common wrong answers will be. They intentionally put trap answers into the questions. They know the mistakes that students will make, and they will put them there. And that makes it extra hard because sometimes if I miscalculate or make a small error, I can see, oh, that's not one of the answer choices, so I must have made a mistake. However, that's not always the case. So it's really important. Part of our practice for this math is really showing our work and being very organized. Organization is such a big key in math that many people don't recognize. Also, penmanship, right? Good handwriting. You would think that that only applies for the essay, but it has far more meaning than you think in the math. Why? Because what if your 1 looks like a 7? What if your, addition, what if your plus sign actually looks like a multiplication sign? What if your decimal was too small and you didn't catch it? There's so many mistakes to possibly make. And when you have so much work to show, this is how much work I had to show for just the first quote unquote easy 3 questions. You can only imagine how much more work we need to show when we have more questions, when we have the harder questions towards the end. And so keeping yourselves organized, keeping my work clean and clear is a really, really big factor here. You will also on the exam have scrap paper, or if they don't give you extra scrap paper, there is plenty of blank space throughout the test that you can use. So the issue usually is not having the extra space to solve it, but it's doing so in an organized manner. 52. Of all the fractions with a denominator of 17 and a whole number numerator, how many are between 1/3 and 2/3? Now, this is the one that I said, well, fractions, numerators and denominators, and all of these words make sense, but what do they mean by this question? And so it takes a little bit of conceptualizing, a little bit of logical reasoning to figure out, what are they even asking me to do here? So we know 17 over 17 is 1. 17 is a prime number. So I don't even know what, half would be, because it wouldn't be a whole number. And it's a little bit, and I think they chose that on purpose. They didn't make it numbers like, 5 out of 10 and then 6 out of 10 where you can easily simplify it. So out of 17, they need us to round. And so what you can recognize is a number close to 17 that 1/3 and 2/3 can fall into. And so I thought of 18. I know that 2/3 is 12 out of 18, and 1/3 is 6 out of 18. Right? This is equivalent fractions. You multiply them both by a factor of 6. And then I notice I didn't put an equal sign, but I put an arrow over here that I actually made it 12 over 17. I made it 6 over 17. Now here's a question for you all. What's bigger, 12 out of 18 or 12 out of 17? How do we know? One of the things you may have learned about fractions is the bigger the denominator, the smaller the denominator, the bigger the fraction. You can see this in slices of a pie, right? 1/2 of the pie is bigger than 1/4 of the pie or 1/8 of the pie. And so these conceptual things that we've learned before come into play in this test. So 12 out of 17 is a little bit bigger than 12 out of 18. And 6 out of 17 is a little bit bigger than 6 out of 18. But since I need to be between 1/3 and 2/3, I need to be a little bit bigger than 1/3, so the 6 out of 17, but I need to be a little bit smaller than the 2/3. So that's why I chose to go from 6 over 17 to 11 over 17. Notice another common trap, and I'll show you why in a second. So from the 6 to 11, so how many numerators are going to put us between 1/3 and 2/3? Well, it's everything from 6 to 11. So 6, 7, 8, 9, 10, 11. 6 numerators. The answer was D there, for those of you who are following along. Now, what were the common traps that I was talking about? Well, one of them was if I kept 12 out of 17 instead of 11. If I counted all the numbers from 6 to 12, then I would have 7. And if I remembered that it was 6 to 11, but I didn't actually count how many numbers that was total and just did 11 minus 6, I would get 5. Both of those are answer choices that are possible here, choice C and choice E. Last one here, number 53. Now this one was a little bit more straightforward, but it still had the possibility of a lot of mistakes in the actual computation. So 15% of the sum of 3 1/2, 7/4, and 0.75. Now the rule of thumb here is you have to pick a format, whether it's fractions or decimals, and convert all of the terms to that. So in the first example on the left-hand side, I converted them all to fractions. 3 1/2 I converted to 7 over 2 plus 7 over 4 we keep, and then 0.75 I turned to 3 over 4. And because we're adding fractions, we need them to have the same denominator. So I made them all out of 4 for a total of 24 out of 4 and 6. Now look at that. I did all my addition, right? And I got 6 as an answer. Notice how 6 is an answer choice. I mean, I did all this work, right? And if I'm speeding through this test and I do all my addition, and then I see that this is an answer choice, you would be surprised how commonly people get this wrong. They see, okay, some of these numbers, but then forget that what I actually have to do is find 15% of it. So D's wrong. We need 15% of our 6, which is actually 0.9, which is answer choice C. The other possibility was to use use decimals for all of them to convert all of our terms to decimals. So 3 1/2 would be 3.5, 7 over 4 would be 1.75, and then 0.75 stays. They add up to 6, and then we take the same approach of taking 15%. Like I said, even in the very first 3 questions, look how many traps we were able to find. That's what makes the 100 test hard, not any advanced math skills. I'll pause in case anyone is writing this down or has any questions about this. And I see one question in the chat about the format of the 100 test. So last year, the 100 test was still on pencil and paper. To our knowledge, it is still pencil and paper. But seeing how the SHSAT and other tests have changed very quickly, we don't know if there will be any announcements about it converting to being online or otherwise. So as of now, still pencil and paper. And we try to keep everyone apprised of any changes that happen. And yes, it has been a Scantron. So it was a Scantron for your multiple choice, and then the test booklet would have the essay. That's usually the essay pages are separated and of course graded separately. And so that essay, it's important, we'll talk about this more tomorrow when we talk about the essay portion, but because the essay portion is handwritten and then graded just by looking at the paper, right? Penmanship is really important. Writing neatly in a way that's coherent, understandable to someone who, has been reading 500 essays throughout the days. But the multiple choice will be on a Scantron. So, and that also comes into play when we say that you can do it in any order you want. Something to also be practicing is if I skip forward and do the math section first, of course I have to start bubbling from question 51 and not question 1. Really great questions. Happy to take more as we go along, and let's do some more math. So this was just the very first few questions. I have a couple more from throughout the exam. Here's a good one. At the bottom is a completed addition problem with all the digits replaced by letters. Every letter represents a single digit, and different letters represent different digits. Which digit might the letter T represent? Now, on first glance, this might look like something you've never seen before. It might seem like a strange type of question. What do you mean an addition problem, digits replaced by letters, right? They're kind of giving us a long explanation here. Believe it or not, this is a pretty common 100 question, and we repeat this in different formats to practice all the time. And so by practicing and through our course, we will learn so many of the commonly tested patterns that students immediately will learn how to approach a question, immediately know how to approach a question like this when they see it. So what do they mean? They mean that these MH plus MH equals TM, that the letter H stands for one number, the letter M stands for another number, and the letter T stands for a third number. And we have to figure out what number T stands for. But as we see, we don't have to not only figure out T, but we're going to have to figure out all 3 of the letters to be able to solve this. But how do we start? Now, if you remember, I talked about earlier today that there's often a brute force method, and that's what we try to avoid. Now, I could write out all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and start plugging them in. But how many combinations of 3 numbers could I have? A lot. So I have to do this in an efficient way. And so we oftentimes take time when we approach a new style of question, figure out what are some of the things I should look for? What are some of the things I can notice to approach this question efficiently? Now, one thing I'll point out is, well, it's a 2-digit number added to itself 3 times. So it's 3 times a 2-digit number, and it still adds to a 2-digit number. So that is actually extremely limiting. Because if M were 4, what would happen? the smallest it would be is 40 plus 40 plus 40, which would give us a 3-digit number. That's a huge hint for us. That means that m must be less than 4. Can it be 3? Can it be 2? Or can it be 1? Now, I asked myself, can it be 3? Well, not only do I have an m here, but I also have an m here. So if this is 3, because we said, m plus m plus m could be 3, like this could be 9, for example. If this m is 3, what does h have to be? Right, what number would this have to be to add up to 3? This could be 1. So one of my answer choices could be that h is 1, m is 3, and then t is 9. But 9's not an answer choice. So what do I do? Okay, well, we said we had other options. So m could also be 2 or 1. It can't be higher. Well, it can't be higher than 3, so I guess we should include that in here as well. So then it's not brute force anymore, because now I have significantly reduced the scope of numbers I have to try. I have to try the answer choices where m is 1, and I have to try the answer choices where m is 2, on top of the one that we just tried where m is 3. So if we try 1, I have to ask myself, what number times 3 ends in a 1? Now that's tricky, because we would say, well, no number times no number plus itself 2 more times is going to be 1, right? But it could end in 1 if we think about the carryover. So there's a lot of the times in these questions, there's small little things that we always have to consider as, well, what about this? What about that? So here, what about a carryover? So 1 times 3, no. 2 times 3, no. 3 times, right? And so here, 7 works. 17, 17, 17, 51. Look at that. M could be 1, H could be 7, T could be 5. I see some of you guys got that right in the chat. Great job. That's one possible answer. Now we said, what about 2? You could, in theory, stop here at 5 because you found your answer choice. But to be thorough, and something we would check in class, especially as good practice for a future question, is try the other possibility. What number times itself 3 times ends in a 2? And 4 does. So 4 plus 4 plus 4 is 12, ends in a 2, carry the 1, 2 plus 2 plus 2 plus 1, 7. So you could have 24 times 3 is 72, where m is 2, h is 4, t is 7. 7 works. But look at that, it's not a possible answer. Our only possibility is 5. So that's our answer. And so what's good about this question, and similar kinds of questions like this, is that once you have an answer, and once you've proven it, you kind of have a little bit of confidence that you got this right. Because I can check, right? My m's are all the same, my h's are the same, my t's are the same, it adds up. I'm pretty confident that I got it right once I'm able to solve it. But again, if I were to work backwards from the answer choices, this would be really tough. Because even if I plugged in all of these choices for t, to work backwards to find m and h would be significantly more challenging. Let's look at another question. A magic square is a square where the sum of the entries in any row, column, or diagonal is the same. For the magic square below, the value of a is what? Another example of a question where you might say, what's a magic square? We've never learned this. I've never seen this before. This is also very common on the test. You'll get questions where the concept behind it is it's really just addition and multiplication. Fairly simple algebra, but it's presented in a format that's incredibly unfamiliar. And that's what throws off many students, and that's what makes it hard. And that's what we practice: the pattern recognition, the logical reasoning, the problem solving. So what do we do with this magic square? Any row, column, or diagonal is the same. So in any row, that means 2x plus 10 plus a is the same as 3x plus 3 and x plus 7. And then these are the same. And these are the same. Now that's a lot of marking up. So what do? Here's an explanation to it. We don't have complete diagonals, rows, or columns. So how do we utilize every entry that's given to us in the fewest number of equations? So one way that we can solve this is by adding in an unknown c in the middle. The reason that we can't do it like we originally showed this way or this way is because the number here, this could be D, this could be E, this could be F, right? These numbers could all be different. So what is going to keep them all the same is the C in the middle. Now let's consider the diagonals that would form the 4 entries that are given to us and our variable C is considered. This is what I call problem solving. Right? You're presented with a question, you can identify that there is going to be issue places, right? There's places where you're going to run into problems. I'm going to run into problems with, these different squares that are all blanks. So what do? Right? And the solution here was to find something in the middle because that would be most applicable. So here's what they did. They took our 2x plus 10, our c, and our x plus 7. So they took this diagonal and said, well, it's equal to our other diagonal, 3x plus 3 plus c plus a, right? That's the trick, to find that what they have in common is the c and to use that. And then from there on out, it's algebra. And it does look scary at first because it's long, but none of these terms are complicated. None of these are big numbers. Just simplify them. And it's all addition, right? We don't have to distribute anything. So if you look over here, they just simplified 2x and x is 3x, 10 plus 7 is 17, plus c. And here we actually couldn't simplify anything because we have 3x plus 3 and then 2 variables. Now again, this looks a little scary because we have we actually have 3 variables, a, c, and x. But if we just stay organized, it's no more complicated. And then they got rid of the c on both sides. That's not shown, but they subtracted c from both sides. And they subtracted 3x from both sides. Remember, simple algebra, whatever you do to one side, you do to the other. So if I subtract something from one side, I subtract it from the other. That leaves us here. 17 equals 3 plus a. This super long equation is just 17 equals 3 plus a, where a is 14. Which is answer choice E. Hope that makes sense. Let us know of any questions. And then we'll do one more. Another type of question. This one is a question that I call visualization. Examine the pattern and determine how many more shaded squares than unshaded squares will be in this 100 by 100 square, will be in the 100 by 100 square in the sequence shown in the diagram to the right. So here's our diagram. We have a 1 by 1 square, a 2 by 2 square, 3 by 3, 4 by 4. So examine the pattern. They're telling us this is a pattern recognition question. So then what's the question? How many more shaded than unshaded will there be? And so one of the things we teach in our classes is, okay, when we know that we're looking for a pattern, what do we need to do? We have to use the information we are given to figure out what the pattern is. How many more shaded than unshaded squares are there? And how do I continue this pattern forward? Am I going to count all the way up to 100? No. Now, what I've seen students do is if you're really resorting to, brute force, is you can, in theory, try to make a diagram that has 100 rows. Now, I'm obviously not going to do that, but you can try. Or you can try to work up maybe, say, 10 by 10 and see the pattern there. But what we try to practice is, avoiding that. So you could say, okay, there would be this one, and then the next one, and the next one. And so this gets messy. So how do we do it using math and pattern recognition? Here it is. Given a sequence of n by n squares from 1 to 4, each of which consists of a smaller 1 by 1 shaded and or unshaded, they want us to find the difference in shaded and unshaded 1 by 1 squares for the unshown, right, the one we can't see, 100 by 100. So here's what they did. They found the pattern using the information we have. In a 1 by 1, the difference is 1. In a 2 by 2, they said shaded is 3, unshaded is 1. The difference is 2. In the 3 by 3, unshaded was 6, shaded was 3. The difference is 3. And lastly, in the 4 by 4, the unshaded was 10, the shaded was 6, the difference was 4. What do we notice? That in the 1 by 1, the difference was 1. In the 2 by 2, the difference was 2. The 3 by 3, the difference was 3. 4 by 4, the difference was 4. So what does that tell us? That the difference in the shaded and unshaded squares for each of the n by n square is n itself. So in our case, it's going to be 100. It's pretty neat. Now this is a written out explanation, right? Here, they drew it all out. They wrote number unshaded, number shaded. Is that what we're expected to do when we're trying to solve this? And, are we doing it to write all this when we're trying to solve this question in 2 minutes? That would be my question. The answer is no. You can do this in shorthand. And the hardest part and the most time consuming should be to figure out the pattern and figuring out what do I need to do. So I could say, okay, difference here is 1, obviously. Difference here, I could say, okay, there's 3 of the, sorry, I'm using the wrong. I could say, okay, there's 3 shaded, there's 1 unshaded. Difference is 2. What about here? Unshaded 1, 2, 3, 4, 5, 6. Shaded 3. Difference is 3. Here's where I should start thinking, this might mean something. And then same thing here. I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And look at that. 10 minus 6, the difference is 4. Here is where, the bells go off. Now I have confirmed I found my pattern. All it took was counting the boxes, right? So 1, 2, 3, 4, I have a 100 by 100 box. My answer is 100. I'm done. This is how I would solve the question in real time. Did I show a lot of work? No. Did I spend a lot of time? Also no. All I needed to do was find the pattern. And so it took the critical thinking and all of that to figure out how would I approach this. And sometimes, you may or may not know that there's a pattern like this. And chances are you don't. So when I don't know what a pattern is, all I can do is start by figuring out a pattern of what I already do know. And so I wrote it out. And that's how I would solve this question. This is another example of a typical Hunter question. Again, notice no complex math, no formulas, none of that. And lastly, I'm not sure if I don't have explanations for these, but just to point out a couple more things. Another question here. A rectangular floor of a room is 4 foot 6 inches wide and 8 feet 3 inches wide. How many square yards of floor covering will be necessary to cover the floor of the room? So the trick here is to know that square yards and square feet and square inches are all different. You don't even need to memorize the conversions between yards, feet, and inches. They tell you. Though this is something you likely already learned in class and probably know, but they will give you these reminders, right? They're not here to test your memorization of formulas. They want to know, can you figure out what a square yard? You may know that 1 yard is 3 feet, but what about 1 yard squared? 1 square yard is not 3 feet because it's 3 feet each way, which means 1 square yard is actually 9 square feet. That's conceptual. And you need to figure that out to solve this question. And as we cover in class, once you learn this, you're going to keep using it. And another question for demonstration, how many numbers less than 51 are a product of 2 different prime numbers? And they say, reminder, a number is prime if it is only divisible by 1 in itself and no other numbers, and 1 is not considered to be a prime number. It's another example of they don't need me to memorize what are prime numbers. They'll tell me. But now I have to figure out how many less than 51 are a product of 2 different prime numbers. And this is the explanation for it, is a little bit more of a brute force kind of question, where first they wrote out most of the prime numbers and then thought which ones can be multiplied to get something less than 51. So if we look here, right, they start writing them all. Then they narrow down ones that we can multiply at least by 2. And here they actually wrote out all of the multiplication. And one of the things that we cover in class is, okay, how do we do this so it's actually efficient? Do I need to write out all of this multiplication? No. But how can I do it so that I don't miss anything? These are skills that we learn in class. These are just some examples of the math questions that you can find on the Hunter test. So thank you so much for tuning in, and I hope you're able to work alongside us and catch some math problems. I'm happy to stick around for a couple minutes to answer any questions Like I said before, I'm a graduate of Hunter High School. I've taken this test. I know what it's like to be in these shoes. So I'm happy to answer anything about the test, the school, our Kweller classes, and so forth. Have a wonderful evening.
Hi, quick question. So for the real hunter exam, do they give them a bubble sheet? So obviously they'll give them the test. Is there a bubble sheet where they have to put the multiple choice answers in?
Yes.
Okay.
And if you guys tune in tomorrow, we'll talk about the essay portion, which is also very unique and a really great part of the exam. So hope to see you all back tomorrow and happy to answer any questions. Is there a break? No, or at least not a prescribed break. So you have 3 hours, like we said, total free reign on how you use it. So if you need a break, you take a break. But that is something also to consider about the time you have. So we always recommend, obviously, go to the bathroom before, make sure you have eaten and all of these things so that you limit the amount of breaks that you need.